All right, so welcome everyone back to the third day of the symposium. And yeah, I wouldn't wait for so long, but introduce now Tristan Behrens, our next speaker. Dr. Tristan Behrens is an expert in artificial intelligence and deep learning, having accomplished a diploma in computer science as well as a PhD in artificial intelligence. Tristan Behrens currently works as a hands-on advisor, teacher, mentor, and strategy consultant within the field. Within his work, he focuses on deep learning for natural language processing and image processing, bridging the gap between data and developed neural networks, augmenting human creativity and productivity with AI, and increasing the multiplication of AI knowledge and experiences. Tristan also works as an AI musician, a passion we get to visit and learn about during this workshop today. So thank you, Tristan, for joining us, and the stage is yours.
Most welcome. Thank you very much for the kind introduction, and thanks everyone for being here on this lovely Sunday. Today I'm going to talk about composing CyberPunkMetal with GPT-2. GPT-2 could already maybe excite a couple of you because this is one of the big natural language processing deep neural networks, a transformer. And while CyberPunkMetal comes from the nature of how my music sounds, it's not really easy to put it into a certain genre. And I'm going to tell you a story about from zero to Spotify using deep neural networks, which is actually a journey from an idea to something published on the internet. I was already introduced. To put it in a nutshell, I usually say that I'm a musician trapped inside the body of a computer scientist. So actually I started programming first and also had a couple of other interests, including art and music. And now I'm in a very happy situation that I can actually merge the creativity and the AI part. Makes me very, very happy. When I did my PhD in artificial intelligence in 2012, it was not really at the horizon, because compared to today, 2012 was like dark ages of artificial intelligence. We were not really talking about deep neural networks here in Germany as much as we do right now. And now I see, especially in Germany, but also everywhere in the world, we are talking more and more about deep learning and other approaches in artificial intelligence for creative endeavors. Also, kind invitation, if you'd like to connect with me, you can just put my name in Google and you find me on Instagram, LinkedIn, and also on YouTube. Happy to connect. Always reach out if you have a couple of questions and comments. I would be happy to react. Well, I call it like biblical 50 days because coincidentally, my journey started on Easter, ended on Pentecost, which is like 50 days of something happening in the Bible. And it started with that I had the idea of implement a paper that a friend of mine suggested me. It's called MMM. It's about multi-track music generation. I'm gonna talk about that paper later, which I found extremely fascinating because first and foremost, it uses transformers for music and promised to be extremely flexible in composition. So what I did, I implemented that paper. Unfortunately, back then there was no code for it yet. So it was just a paper, but the paper was so well written that I could do that myself. And now if you find on papers with code, that paper and the code is actually mine that I've published. So I gave something back to the community. And I implemented it on JSB. We heard it already, Johann Sebastian Bach Chorales. It's a data set of approximately 400 chorales by Johann Sebastian Bach. And I also used Hugging Face. It's a very, very nice company that is specialized on transformers for natural language processing. And this whole thing, like implementing this paper on the Johann Sebastian Bach Chorale dataset, that was the Easter weekend. It turned out to be extremely comfortable with Hugging Face. And then while continuing my journey, I wanted to go away from this hello world of chorales towards something that maybe not so many people do. So my idea was, well, let's train it on heavy metal music. So setting the bar a little higher. So usually in deep learning, once you start doing something, the first task you do, the most amount of energy and time you invest in the whole data. Deep learning is something where you also spend some time, but it's usually not that much. A couple of years ago, you would spend 80% on the data and 20% on neural networks. Now with software like, for example, Hugging Face, it's up to 90% data and 10% to neural networks. I had to get a big enough data set. and we already heard about sources for getting data sets. I focused on MIDI files, which I'll tell you is already symbolic transcribed music, so not working with WAV files or MP3s, but on the MIDI files. And also like annotating those files, which subgenre they are in, because there's heavy metal and there are also a couple of subgenres in it, and they differ quite a lot when it comes to how the music sounds. And that, data scientist usually, this is what data scientists or data engineers especially do quite a lot. It took just maybe 1 or 2 days to get the data and annotate the data. Did not take that much time. It was just me sitting down, writing a couple of scripts, pushing a button, and after a couple of hours, I had the data set up and running. What took a little bit more time was taking the data set, those MIDI files, and map them to something that a natural language processing transformer can understand, so putting it into a text format. But that's just a transformation algorithm. I think also adds to, maybe it was also in these 2 days that I mentioned. And then training a couple of neural networks for experimentation. I didn't do that much hyperparameter tuning. I just took one neural network, but it was more about like the size of a data set that I had to experiment with, fixing a couple of bugs. I tell you, if you do transposition, like going in the pitch up and down, don't do it with the drums. Drums are pitch agnostic, don't do that. Might cost you a couple of euros. But in the end, I would say it was 1 or 2 weeks training neural networks. And the last neural network that I've trained in that time is the one that I'm still using now. And I trained it on 7,000 heavy metal songs, trained it for 4 days, like 4 days on 4 GPUs. Like happily, I'm good friends with a company for NLP, and they gave me access to the cluster, so I could do some training there. I was very, very happy, and I always mentioned them as I did now. So this is for you, Pioneer. Thank you very much for supporting my work. And then, once you have a neural network, it's quite nice. You have something that can predict something, but you still have to bridge a gap between the stuff that the neural network creates and your software for music production. Plus, you also have to put it into something like a tool that provides you some functionality, undoing things, deleting a couple of things, continuing something, doing a couple of buttons. I'm going to show this too today. Implementing Composer tool, just Jupyter notebooks with a couple of widgets up and running in almost no time. Did not spend that much time on that, but I'm always extending this one to give it more functionality. So today I'm going to show the tool in its current incarnation, which is a little bit more sophisticated than the early one. And then, now comes the big part and the best part. Having the neural network up and running, trained on quite a lot of music, composing and producing 12 songs. Like sitting down and doing the magic, getting notes together, doing something with the notes, turning this into something that I like to hear when it comes to the sound, doing the mixing, doing the mastering, having 12 songs up and running. And then, getting cover art, finding a band name. The band name is Hexagon Machine, actually comes from a dialogue that I had with GPT-2, I think. There's somewhere write with transformer where I could write, and then I gave some description of what the music is going to be about and asked the AI to suggest a couple of names and did some brainstorming together, and Hexagon Machine was the one that stuck. Also finding song names. Usually I just give my song names, my songs numbers, but this time I kind of set the mood. I told GPT-2 again, I have an album, so many songs, it's composed by AI. It has the title Robot Uprising 2021. Please suggest a couple of song titles. And then it said 1, 2, 3, 4, 5. Really worked like a charm. And then, of course, like uploading it to all the platforms, so for our listening pleasures. So you're going to find Hexagon Machine on, I think, everything now, including YouTube. So long story short, 50 days from the idea via the implementing part, doing a couple of experiments, coming up with tools, including composing 50 songs with AI. Not 50, 12 songs with AI, releasing it to the public. So that's the entire journey. It was quite exciting. After that, I started a second album with all of this in place. The second album, Digital Dawn, just took 2 weeks with 1 week in between where I was on holiday. And I'm now working on a third one, which is going to complete the cycle of 3 AI albums. I think this morning I finished the 9th, and a couple of hours ago I started the 10th song, so I'm still on track with that. Well, it also included a couple of experiments. We already heard about the Johann Sebastian Bach Chorales. Again, this is the hello world. If you have a neural network and you'd like to test it, this is where you start. The dataset is freely available on the internet. You don't even have to think about copyright issues because unfortunately Johann Sebastian Bach is long dead. And every time you run into maybe a deep neural network or some generative AI, there is a high chance that this has been trained on that dataset. And after that, second experiment was that I trained it on 1,400 rock songs, which also contained a couple of hundreds, maybe 300 heavy metal songs, where I thought, maybe this is going to be slightly more complicated because, well, the structures are differently, and also the rock and heavy metal music, they contain drums, which you don't have in the music by Johann Sebastian Bach. And when I saw that, just training it on that few amount, 1,400 songs and MIDI files, I saw that it worked. And then I decided, well, okay, let's go bold, grab 7,000 heavy metal songs and just go wild. And this is the whole story. And those experiments in the 50 days. Dataset. I think this is a very, very nice visualization about how my dataset is composed. So those are the 7,000 songs. I sorted them, or I annotated them, or conditioned them on different genres. And those are the genres that were actually, or are actually in the dataset. And the bigger the font, the more data I have. So obviously heavy metal has a sub-genre called heavy metal, but there's also thrash metal. This is what I grew up with, and Metallica and Megadeth and these things. Was quite happy to listen to those in the 90s. Also little stronger stuff like death metal and black metal is in there. If you would like to have a little bit more glitter, there's glam metal in it, and also metalcore, folk metal, and power metal, and so on and so forth. They all have different variations of how they compose music. But this is, well, how my dataset looked like. So there's something hidden for everyone, I think, in it. So everyone that kind of knows about heavy metal should feel at home in that. What I can say is that when it comes to the composing style, like what kind of harmonies they produce, power metal is my favorite. Power metal is not the music that I listen to on an everyday basis. I'm really leaning towards electronic music, but when it comes to the chord progression and the harmonies, power metal was quite nice. If I wanted to have a little bit more erratic, I switched to thrash metal. So they had very, very nice bass lines and then doubled by guitars. I liked it too. And today I started with black metal. So one song that is very black metal-ish. So this is going to be my musical challenge, my musical sacrifice for the next couple of hours, I think. So, but that's it, dataset. And again, dataset is the single instance that is your path to success. If you don't have a big enough and high quality enough dataset, then your whole endeavors are going to fail. Well, next question would be how to actually train a neural network on that. And there we can take a lot of inspiration from our big brother, natural language processing. Natural language processing, quite a lot of use cases, including translation and things like sentiment analysis. And there is one thing that I like a lot, language generation, and usually makes use of a thing called, or a principle called, autoregression. And the idea is that you have a sentence, a piece of text, like for example, Harry Potter, a student at Hogwarts School of Witchcraft and Wizardry is a great. And then you ask the AI, the deep neural network, to predict the next word. And you can imagine that, well, there are only so and so many words that would make sense. For example, wizard, hero, boy. Those are the ones that make sense. And if you have a good enough neural network, a statistical model trained on all the works by J.K. Rowling. And fantastic thing is that you can repeat this. So once you've predicted, for example, wizard, you could also feed that into a neural network and predict the next word and the next word and the next word and the next word. And this is how the big neural networks, like for example GPT-2 and 3 work. They are all about, given a couple of words or tokens, predict the next one. In music, well, it's the same. Let's assume we have a couple of notes. Which one is the next note? And we think about, if you have music, We heard this before in Werner's talk. When you have such randomly initialized neural network, you get just noise out of it. And once you put more structure in it by adding musical rules, the whole thing gets more and more harmony. And this is like something that a neural network has to learn over time. And usually the neural network learns this by training on quite a lot of data. So let's continue. We already heard about them, the transformers. Transformers, very new, comparatively new. I mean, we're talking about a paper release at the end of 2017, a code release at the beginning of 2018 with attention is all you need, which was fairly impressive because now it lifted the bar of natural language processing translation very high. And we got a couple of promises that in comparison to other models like recurrent neural networks, LSTMs, prediction is going to be very stable. It can be trained on more data, and also it can model those inter-word relationships way better because it takes very long sequences, and it also trains faster than LSTMs. So what you see here is the original transformer from the Attention is All You Need paper, which, well, if you look at it, inputs and outputs, is a translator. Input is a sentence in one language, and the output is a sentence in another language. So you put in a sentence in one language, and it word by word generates the translation. We heard about BERT, which is about language modeling, like which is the missing word, for example, representing texts as vectors. This is the left side of this picture. And GPT-3, I think it's slightly more famous than BERT because of the fear of fake news that we had a couple of months ago, is the right side. So GPT-3 is just an autoregression. It's a neural network that just predicts the next word, and it's fascinating what it actually can do. When a big difference, so I'm switching between GPT-2 and GPT-3. Well, the biggest difference is the size. Because here you see this on the right side and left side is NX, which tells you that this block is going to be copied. And I think GPT-2 and GPT-3 has an X that is 96. So these are very, very big neural networks that you cannot train at home. You need a cluster for that. Well, continuing, how to represent this in a format that can be used by natural language processing models. Well, this is a Bach chorale. Heard about that? It's music for not so, how can I say, not so professional people. First and foremost, singing in churches. You have 4 voices: soprano, alto, tenor, and bass. So 2 female voices, 2 male voices. And what you have there is music that can be sung by those people. So it's not too complicated. It's not the magic flute by Mozart. It's something that people can just easily learn and then sing. And the magic behind that music is that it's harmonically very, very sound. So the whole harmonies, the chord progressions, they're very, very sound. So if you look at this, you always, or almost all of the time, you have the basic triads. So if you know about music theory, there they are. It's usually also something that you learn at the beginning when you start composing, like how to harmonize, like Johann Sebastian Bach. So you get a melody. What are the missing voices? Here is a representation of the same piece of music, or a piece of the piece of music as a text. So what you can see here, piece start. So this is a word indicating that the piece is about to start. And then track start. Okay, we have multiple tracks. In this case, 1, 2, 3, 4 voices, 4 tracks. And then it says instrument is bass, which points it in the direction. Bass is the lowest voice. It's the red one that we see in that piano roll. From left to right is the time. Top to bottom is the pitches. So this is something that people who are into music can immediately recognize. So what it says here is note on 61. So the note 61, which, well, I have to do the math, what note it actually is that one. And then this time data 4, which means 4 semiquavers, so one quarter note. That's what you see here, and then it stops. And then the next one starts and it stops, and so on and so forth. So this is the whole red progression of notes here that you see here. And then, of course, it has, well, not of course, here in this case also has an understanding of where a bar starts or where a bar ends. So this music is here 1, 2, 3, 4 bars. And also here at the end is track end and then track start. And in this case, now the blue one starts, the tenor. and would continue like this. So if you have this as a MIDI file, you only have to sit down and write a generator that would take the MIDI file, like take every track out of it, every voice out of it, and put it in that notation. And once you have this notation for all your files, for over almost 400 files, you can throw this into a transformer. Transformer would train on that and would then be able to, for example, compose a single voice, given a voice, compose the next voice, given 3 voices, compose the final voice that is missing. So, but heavy metal, different thing, but as it turned out, same ballpark. Big difference that I already mentioned is that now you have drums, which are like, it's more like events bass, does not really have pitches. It's more like you have a kick drum and a snare and hi-hats and cymbals, different crashes and so on. And the usual structure is, which makes it also a little easier to understand, I think. You have layers of instruments. So you have the bass guitar, dum, 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 playing something in the lower bass regions of the frequencies. And then on top of that, you have stacked usually guitars. Maybe it's 2 left and right. You maybe have a rhythm guitar, you have a solo guitar, you have a melodic guitar, you have it there. And sometimes, and this depends on what kind of music, of what kind of band you listen to, you won't find it in Metallica, but you might find it in Nightwish, that you have something on top of the guitars. For example, some piano or some synthesizer or a couple of strings. Symphonic metal is orchestral music. So plus they squeezed in the guitars, makes it extremely interesting, like harmonizing with an orchestra, your already existing guitar track. So what I did is I restricted it all to, well, if there's something else that is not guitar or bass guitar or drums, then I just call it other and I map it to piano and train on that. So if this is successful, at least I hoped, I could generate drums, I could generate the bass, guitars, as many as I like, and also something like piano on top of it if I like. And also in that order that I decide. So maybe I start with bass, maybe I start with drums, maybe I start with guitar. This is very important because Hugging Face proved to be the biggest time saver. So remember that in these 50 days, I implemented a paper and published the code. And this paper was extremely great for me to read because it just focused on the data representation. So like you take this data, you do these transformations, you put it in that format, quantization and so on and so forth. And then there was like 2 or 3 sentences. I don't think it was an entire paragraph saying, and then you take GPT-2 from Hugging Face with these parameters and then you train. So no whole chapter, no whole section about the new network architecture, just said, Hugging Face, GPT-2, these are the parameters, go. And then, well, I did it, worked like a charm. I did not do any fine tuning with the new network architecture, nothing. Just threw it in and it worked right out of the box, which tells us that we are now on a threshold of like deep learning where you can almost ignore the neural network architecture because those neural networks are quite powerful. Just to show you a little what you have to make sure is when you train a neural network on music or on text, you first have to get a tokenizer, which takes a look at the text and then finds out the tokens, like node on, node off events, piece start, piece end, track start, track end, bar start, bar end, and so on and so forth. And then maps it into a format that the neural network can understand. We heard about this, well, have to be mapped to numbers. And as soon as you have numbers, the neural network can train on that. Continuing, well, with Hugging Face, it's fairly easy to instantiate GPT-2. And here, quite interesting for you, those transformers usually have multiple heads. I used 8 heads in parallel, and the height is just 6. So when you remember the picture we've seen before, the blocks, amount of blocks is just 6. And also positions, or NCTX, is almost the same here, is the amount of tokens that I have for one prediction. And it turns out that 1024 is enough to model 4 bars of those 4 instruments that I've mentioned. So drums, bass, guitars, and piano. So that works without problem. I could go up, and I did in one experiment. I went up to 2048 to model 8 bars of music. Turned out that using it as a tool, it did not make a difference. So the 4-bar model was already enough. And then, well, you just train it. And I'm showing you this to show you that it's only data, and then you invoke Hugging Face, and then you can just go, because you don't see the neural network. So I'm trained to really stack layers on top of each other, create neural network architectures, do magic with loss functions, and so on and so forth, train neural networks. But here, you just throw in the data and it works. The trainer trains the neural networks, has a couple of arguments, for example, like how many epochs, how many cycles we've heard before. And then a training data set, which is, I think, 90% of my heavy metal music, and then 10% for evaluation to see how good the neural network is on data that it has not trained on. And that's, well, all. So big takeaway here is that when you start with Hugging Face, the world is going to be very easy for you. And also complicated in a sense because your focus is data only. The neural network, it just works. Probability is very high that it works right out of the box. Well, and then this is the most important part for us, is the sampling part. Like, given a neural network, like, generates something in an autoregression way, if I would take as input ideas here, encode a token sequence, I could just put in p start, and then I would tell, well, predict something. And if you go back, you can see it right here. If I would just provide p start, then the neural network would have a high probability of predicting a track start, and then it would pick one of the 4 voices, because the order is something that I changed over time to make it more general. And then it would predict a bass start, and then it would go wild and produce a couple of notes. And after each bar, it would stop, and after 4 bars, it would go to the next track. Also, you could imagine that if you already have a track, maybe some music that you have created, a tiny little melody, and you say, well, this is the guitar, then you could ask it, give me drums that fit that guitar, or give me bass that fits the guitar, or give me both, in an order that you have to decide. So it makes it extremely versatile when it comes to using this as a tool. So coming back, generate, something that you can do. A couple of parameters for that. The most important parameter is the temperature. We already heard about that. If you have a low temperature, then the degree of randomness is very low. And when it comes to harmony in music, if you have one note or you have a sequence of notes, not all the notes that are possible actually make sense. So there are a couple of intervals that sound nice, intervals that you usually avoid. So, and the best like note that would follow after a note is the note itself. Because this is, from the harmony point of view, the best harmony you can get, just repeating the note. So if you go down, then the whole thing is going to be very, very predictive, and it's not going to do any musical or melodic experiments. Here, temperature is 0.9. In my work, I usually have 1, and sometimes I go up to 1.25, so adding some randomness to that. The higher the temperature, the higher is the randomness, and the more like errors you would get. But errors in creativity, we know, we're always happy accidents, could also boost your creativity. So it's not that bad. So you have to find your temperature that works like today for you, like according to your mood, and there you go. But this is not a thing that I usually change that much. I usually stick to 1 and it works like a charm. Well, custom composer tool. Here's a screenshot, but I have it here as well. As what I've said is that, well, you could invoke the neural network all the time and have some fun with it, but I would like to have some control on it. Like, for example, I could compose all, those are the 4 voices, say all. It takes a couple of seconds, guitar, other, bass, drums. And then you say, okay, that's something. I'll just play it. That's okay. There's a little piano in it on top of that, just those chords. There's a guitar playing something. The bass is really, really reliable, not doing that much, and there's a drum beat underneath it. And maybe I don't like the piano yet, so I say, well, let's give me more piano. And then it does something like here, and I can immediately see, I don't think I'm going to like that. So I do another generation, and I say, okay, let's start like this. What is it? Just going down, but then I say, okay, maybe this is already inspiring to a certain degree. And you remember we heard just in the last talk we heard about this musical dice game by Mozart, where you throw a dice and you get something. Here you would also throw a dice and get some heavy metal music, but the dice has like infinitely many sides. So it's very, very random. You can imagine that you can throw a dice and continue and continue and continue, and the song would get longer and longer. So what I also have here is a go wild button. I still did not manage to turn it into red, but what it does is for a couple of bars, it just continues composition. So I hit it, fingers crossed that it will not destroy anything, and it adds, in this case, 4 more bars, because I want to demo it without you waiting a couple of minutes. I usually start with 4 bars, and then I hit the button and generate 36 more. That takes 1-2 minutes. Then you have a little bit more music. You can see, well, let's listen. So now it's getting really crazy. Now I'm curious what is coming next. Let's go wide a little more. And it already hints at like how composing with AI could work in that scenario. Because this is going to be very crazy. I like that. It's always at the beginning I was extremely hesitant using the material, but then I found out that sometimes AI does these happy accidents, and it really, really inspires me. So this looks, this is very erratic. I like that. So let's listen to that again. Crazy. And this is what I really, really like. Sometimes it generates something that is quite useful. Sometimes you get these things, but every time you get something, you can turn it into something even better. So, and you can easily imagine that, well, I compose 40 bars this way. I find the first 4, and if I like the first 4, I think feeling is good. Then I say, well, compose 36 more. I let it run for a couple of minutes, fetch a glass of water, come back, and then I have something. And this is where like the good part for me starts, because now it gets really, really creative. And what we have learned from Werner's talk is that those neural networks, as great as they are, they have a lot of problems being consistent when it comes to arranging the whole thing. Like, it could be the case that it generates something that sounds like a verse, where you could think, okay, there you could put some vocals, and then it would do like 1 bar bridge and a pre-chorus, and then comes the chorus. But it never comes back to the verse part. It's not repeating itself. So what it can really do on a very close-up, harmonies per bar are excellent. Also, the harmonies between bars are excellent. So if you have 1 bar and the next bar, they are harmonically sound, but it's not repeating itself. And this is something that we humans actually like. If you have just the music meandering through possibility space, not really repeating itself, then we get bored immediately, and then we don't like that. That's the elevator music, that the moodsuck, that we actually do not like that much. And this is where we see that this is not composing by AI. So it's not that the AI creates something and then I put it on Spotify. It's composing with AI. So I get something from the AI, and then I turn it into some better music. So let me show you. This is a fine example of something that the AI spat out. I think maybe it was on Friday or something. So I used the tool, I let it go wild with the button, and then it composed something, and I'll show you a couple of things in it. So again, what you hear is very consistent, but it's just meandering. It's not coming back to things that make sense. And I usually consider this as a huge like treasure trove of inspiration. So I take a look at these files, and then I find out, and I look for stuff that I like, and I think maybe this would be a very good chorus. This would be a nice verse. And then I for example, find that one, And I kind of like that one here. And then I get a certain feeling, like a hunch that this might be something really, really good. And then I see if it does it repeat well. One more time. Very nice. So I already found something that I could work with. So you can easily imagine that I would take this whole thing that the neural network has created and I chop it into pieces, and maybe I change a couple of things, and then I glue the pieces back together in a thing, like something that makes sense in my world. What I actually almost never change are wrong notes. Like if you listen to a piece of music and there's one note which is off, get this cringy feeling. Never with this. I had this with LSTMs when I trained LSTMs like last year. Always something where I think, oh, this is not so nice. Like gives me goosebumps. I have to change that one note. Never with those transformers. Sometimes, because I did not change the format on training yet, sometimes it changes the key. It modulates. So it maybe goes from A to E, because still neighboring and it still makes sense, and then maybe it goes back if it likes, or goes to some other key. And I usually like to, I'm a very simple person. I would like to have 4/4, like, this is the beat that I like. And also, when it comes to keys, I would like to have one key in one song. I almost never modulate when I compose. So that said, this is the music that comes from the neural network. And you see there's this creative process of editing. And when you think about creativity, for example, when writing things, you can make a big distinction between like being creative in a sense that you write something down, and then being creative in a sense that you edit the whole things. And people who teach you how to write say that first you write everything down, you ignore style, you don't want to make it beautiful, you just want to get your ideas on a paper. And then you switch to the other mode, where you edit the whole thing and make it beautiful. And well, people researched and found out it's two different pieces of your brain that you're actually using, and don't oscillate between them, have one and then have the other one. For me, getting creative ideas is pushing a button. Like, okay, it's just pushing a button after 50 days of work, getting the whole thing set up. And then it goes into the editing mode. And the editing mode is where I have the highest degree of creativity. So if I end up with something, usually it's a lot from the neural network. Sometimes I add a couple of nodes, sometimes I remove a couple of nodes, but usually it's that material. So let me show you. I have another one here. This is an example of, like, I took the MIDI file you saw and I found something, and here it's already arranged in a sense that, well, this is something that I'm going to turn into a song. It's the same piece of music that you heard before, but it's slightly cleaned up, and I mapped everything to piano to not to get distracted too much by the heavy metal sound. And this is where you see it all the time, that the harmonies really make sense. So although for the untrained ear, heavy metal seems not to be that sophisticated, when it comes to the harmonies, it's very comparable to classical music. So let me show you, like, moving from one thing to another. Now comes the thing again. And this is like a pre-arrangement, like everything cleaned up and chopped into pieces. And then I create another file. And this is the one that is the song, actually, where I assign instruments to it. So I'm not a real fan of using real guitars here. So what I use here are synthesizers. And then you get something that is like way more electronically sounding. So with everything in it, decorations, adding a couple of synthesizers that just do some atmospheric stuff, starting with an intro here at the beginning, speeding up the whole song, having a couple of things that actually repeat, and then the outro. And this is then something that I would put into a WAV file and master and then publish. This is like starting from a deep neural network, composing something, and then I work. And as you might already have noticed, that I'm a huge fan of actually composing with the AI. So I'm repeating myself here. I'm not really aiming at getting an AI where I just push a button and like a couple of minutes later I have a song that I can put to Spotify. No, I'm very creative. I would like to get some ideas and work with those ideas and turn those ideas into songs. I would like to throw the dice and have something sophisticated that gives me pieces of music. And how it feels like is, well, it's 7,000 songs, so it's a couple of hundred musicians that I actually do jam sessions with, because all those musical ideas that those musicians published, I have there. I say, give me something else. And then maybe something that is inspired by Metallica with a little Pantera in it, maybe a little black metal on the side. And I get all these things. And this also tells you that there's one thing that I, as a creative being, am not suffering from. It's creative block. I don't have that. Writer's block is a thing of the past, because I never have an empty piece of paper. So I just click a button and I get something, and there you go. And then I change those things around, I edit it, and well, I get a lot of songs. And when it comes to like how much time the whole thing costs, the whole composing part was, when it comes to like really the time, is cut in half. So usually when I spend a good strong 8-hour day on one piece of music, now it's 4 hours. And it really removes a couple of things that I actually don't like to do all the time, like clicking the drums, like from scratch, those drums. I don't like that. Finding someone else. No. I get everything. It's already consistent, a couple of voices, including bars, including drums, and I continue from there. So very nice. So we saw the composer tool and production in Logic. Very important, standing on the shoulders of giants. So I did quite a lot of experiments with different neural networks. So I created and trained neural networks from scratch for music. I think on my YouTube channel, you can see me composing things with the LSTMs and did experiments with TonicNet and Bach Chorales. I had very, very good experiences with Magenta, which we already heard about. It's very, very strong, especially the music VAE, which I really love, because then you can do math with pieces of music. And it even has a model that works with multiple instruments at the same time, so that you get a melody and a bass and drums, I think. Did not work for my music because I had different ideas. Magenta is very good for initial experiments, but if you have too crazy ideas, then you have to really take it apart and then reassemble it. And my ideas were a little bit too crazy. But that said, MMM, Exploring Conditional Multitrack Music Generation with the Transformer, is like a manual how to take MIDI files and map them to something that you can then feed into GPT-3 or GPT-2 for training. Perfect thing. By Jeff Enns and Philippe Pasquier, they are thinking about publishing their code, but they kind of said it's not ready yet for the public. If you find the implementation on Papers with Code, is actually my implementation, MMMJSB, which gives you like how to train GPT-2 on the chorales by Johann Sebastian Bach with the mapping from the music to something that the AI can understand. So the only thing that, well, thinking about what you have to do if you would like to do similar exercises, the only thing that you have to do is find your data and map the data to the text format that is in here. And then you can just go wild. It has training. I think training on Google Colab takes, I think, an hour or something. It's not as demanding as the heavy metal stuff because, well, here 400 chorales, heavy metal 7,000. Just quite a lot of, well, it's more material. And then if you have it trained, you get a model and you can run a sample here and get some music out of it. Like really works out of the box. And also a little advertisement for what I have done. If you follow the links, and I think I'm going to send you the slides as well, easier for you to click, and maybe I copy paste a couple of things here. There are available the Würzburg winter chorales. So I live here in the beautiful town of Würzburg, and in like last Christmas vacation, I had some time and I trained some neural network, TonicNet, on the Bach Chorales and used that neural network to compose an entire album of chorales. This was composing by AI. So with all the positive and negative things, composing with AI, Hexagon Machine, those 2 albums, Robot Uprising and Digital Dawn, are available now. I'm now working on New Order. Well, the names are all made up by AI, which, well, it tells you that those natural language processing AIs have some bias towards negative interpretations of everything that has to do with artificial intelligence, which I do not share. So you're all invited. Well, that's it. Thank you very much for listening. I hope I could inspire you a little. Again, if you'd like to reach out, just feel free. Add me everywhere. And if you have questions about AI generating music, just feel free to ask. I'm happy to talk a lot about these things. Thank you.
All right, thank you so much for your talk. It was very inspiring, and I'm sure everyone has learned something incredible from it that they can apply to their project.
Tristan, was a really great, great stuff you did at the opposite end of my work from the musical style. But as you said, heavy metal and classical music have a lot in common. Yeah, that's really great.
Really a lot.
Yeah, fantastic. I just want to ask, as you have more experience with this, have you any ideas how to tackle the idea of musical structure of the whole song or so? I mean, like the verse, refrain stuff, or like the idea of the cadence and so on, because you can make it as long as you like. It always predicts. It only looks ahead. It doesn't see it from the end, so to say.
Yeah. The problem with the transformer is, although it works on long sequences, those sequences are not long enough. So if we would have a transformer with a big window that could fit an entire song, with all the notes in between, then I think it would do choruses and verses and so on and so forth. But, well, those are computationally expensive. We have to wait for a couple of years until we have the really, really big sequences. But 2 things. People are working on recurrent versions of transformers, where you have still a big window, where you see all the notes, but you also have a hidden vector of something before, for priming the whole thing. And it's one of, I think, recent releases by the Magenta people, where they have this music VAE, where you have the latent space, and well, so VAE, you have some latent space, and it has some, I think, some flow machine or something that would navigate through the latent space and use the navigation to compose songs out of it. So I think we're fairly close to solving the problem. So yes, this whole new approach by Magenta, which I cannot remember, but if you look it up, you'll see it immediately, is one of the recent publications. They getting closer to that.
Very good. Thank you.
Are there any other questions? You can ask them in the chat and I can relay them to the speaker.
Play us more of the happy accidents. Yeah. Since you liked it, I will just quickly share my screen and we do another happy accident there. And yeah, here comes the screen. So there you go. So where is it? Composer. And now I just go wild, clear everything. And let's take something, black metal. Black metal, something that I could listen to for a couple of minutes and then I get anxiety. So compose all. Seems to work. Doesn't look that bad. Let's see what kind of rhythm we have here. It's not as evil as expected. Okay, and let's do the go wild again. Then we can conclude this demo. Yeah, and this is again what I find extremely fascinating because it bombards me with quite a lot of musical ideas. And when I said that my problem is not that I have not enough ideas, it's the other way around. So what I learned when I started implementing this tool, the most important button is the save button. Because already while programming the whole thing, there might be a very, very nice idea and I don't want the idea to be lost. So I'll save it to a file and there you go. So concluded, let's just listen to it. there you go. Another happy accident. I think it's a term used by Bob Ross when painting oil paintings, and then kind of move the brush and something happened. Oh, let's turn this into a tree. I like this a lot.
Before we proceed with the questions in the chat, there is a raised hand. If I hopefully I pronounce your name right. I think it's Shima. So go ahead.
Shima. Hi. I wanted to ask do you train on different instruments alone, or do you train on all of them at once? Or do you train on just music and then just choose different instruments at the end?
Well, it's what I train on is 4 bars, and 4 bars with usually 4 tracks. Oh, it's the other way around. It's 4 tracks and each has 4 bars. So this is like the structure of that. And what I do in order to make it very general in composition, I randomly switch or swap the order of the instruments. So it might be the case that one sample would start with drums and end with piano, another would start with piano and have guitars and then end with drums. This trains the neural network. The generality that, for example, you could provide guitar and you could ask it, given that guitar, give me the drum, or the other way around. This is a very, very good trick. So I have this data augmentation part at the beginning where I take these things and just swap them around randomly, and it really, really helps. If I would just train in the order drums, bass, guitars, piano, it would only be able to create them in that order.
Definitely.
Yeah.
Do you have your GitHub account where we can look at more examples?
Well, the thing that is available is the GitHub account for the Johann Sebastian Bach Chorales. So you are all invited to use that. What I'm actually not really publishing is the whole heavy metal stuff for reasons because, well, I could think about putting this into a product and I don't want to release the product prematurely.
All right. Thank you.
Welcome. Great question.
We do have some questions in the chat. So Francesca, she's asking, apparently the data training has no directionality, but would it be possible training with time directionality considering music evolution across time and get the next music style?
Ooh, yes and no. This exercise is already an exercise in like condition generation. So I could tell it now thrash metal, if you train on more pop music, what about more folk music and so on and so forth, if we do that. You could also like train it on multiple like time periods. So at the beginning you have P start and then say period is Baroque. And then it would like conditionally generate Baroque music. But the trouble is with those neural networks or with all of the statistical learning methods that we have, they are very good at interpolating, but not good at extrapolating, like really predicting what's next. So if I train it on heavy metal, I'm stuck to heavy metal. Fortunately, as we already found out, there are so many, like it's so harmonious, so many great rules in it that you can cover a couple of other genres as well, getting very close to classical music. So if you have the harmonization with Johann Sebastian Bach, that model can do a similar harmonization. I've seen this in action. It doesn't happen all the time, but it happens sometimes. So, but well, there is like one class of entity that is really responsible of going to the next level, and I hope is going to be the humans that may use one of or a couple of those neural networks to create new styles, and then we would get more data to train on. But that said, interpolating works like a charm. Extrapolating, predicting what is the next kind of hip-hop music, I doubt it.
Thank you. We do have another question. Bello asked about the data set. Did you just collect as many heavy metal songs as possible and then label them, or did you look for specific data first?
Well, the good thing is, well, I got quite a lot of MIDI files. If you look it up, there's, for example, a Lach dataset, which is, I think, Indian for quite a lot. It has 200,000 songs in it, and you can like find out which is the singer or the interpret, which is the band behind that, and you can find out what genre it is. So those are readily available. The only kind of annotation that I did was actually finding out, given a song by a band, what kind of heavy metal is it. Label data, well, it's an autoregression. This is called self-supervised learning. It's a good thing I don't have to come up with the labels. So everything just went automatically. So I never looked up a file and said, okay, this is that and that. Even like things like people do like this conditioning on keys, finding out which key a piece of music is in. This is an algorithm that you can use. So yes, long story short, it is just finding a lot of data and training on it.
And Shaima is asking, did you try training with music that has lyrics in it? Or on music with lyrics, yeah.
There were a couple of prototypes when I did the first album. I didn't mention it on the slides. I had 1 or 2 songs that actually had lyrics in it, so vocals. The lyrics were generated by GPT something fine-tuned on lyrics by different bands. So it's somewhere available on the internet. Maybe it's called Rocknet. I can't remember. So it generated text, which I kind of liked. But my thing was that I didn't want to mix like human sung voice with the artificially generated music. I'm currently working on that. I have this little cooperation with NVIDIA where I use Flowtron, which is a speech synthesis, to generate pieces of vocals and then put them in, but still in the early prototyping phase.
Are there any other questions? No? All right. Thank you so much for your time and your presentation. We enjoyed it thoroughly. It was wonderful and very creative. Thank you.
Very appreciated. Thank you very much.